My passion project is motivated by the fact that basketball shoes fail too quickly. They fail in this exact spot almost every time, and this is due to the fact that while running and jumping, a lot of energy is dissipated in that area. Typically for one basketball season, I'll need 2 pairs of shoes just to get through. Now, I aim to solve this solution by using this micro-lattice material that is currently being used in testing at UCLA in football helmets. Now, their aim with this material using in football helmets is to reduce concussions by reducing the amount of energy impacted into one area. They aim to dissipate the energy over a larger area, therefore reducing concussions. Now, I aim to put that, interweave that material into that area of a basketball shoe in order to reduce the amount of energy that goes into that area of the shoe and dissipate it over a larger area. Now, in order to do this, I will test both the micro-lattice material and the basketball shoe material on the Instron in tension. Currently, I have designed this mode that will, or I've done some back-of-the-envelope calculations in order to test both materials to mimic what's actually happening to the basketball shoe during the course of the season. I estimated that there are 30 meters, or I assume there are 30 meters in a court, 100 possessions per game, 30 games per season. Multiply those together, you have 9,000 meters traveled in games during a season. You have 100 practices during the season, and there's on average 4 times more running during a practice than during a game. Multiplying these numbers together, you have 1.2 million meters traveled in practices. If you add 90,000 and 1.2 million meters, you get 1.29 million meters. And with my stride at 2 meters each stride, you can divide this by 2 and you get 645,000 steps taken during the course of the season. Same with the shoe area. We're calculating this is my shoe area, you get 406 centimeters squared. Assuming my weight being taken at 230 pounds, times 3 for an impact factor, you get 690 pounds, which is roughly 3,000 newtons. Getting the stress from those values, 3,000 divided by the area of the shoe is 75 kilopascals. Now, in order to finalize this calculation, I'll need to know what the strain modulus of the material is, of the shoe. Sorry, the strain of the material of the shoe. That will enable me to calculate the strain that goes into this area of the shoe, which I can then input into the Instron to mimic in order to test both the micro-lattice material and the shoe material. I think one flaw in this calculation is that I don't account for the steps that are taken during a possession on one side of the court. That said, this might be off by a factor of 4, which is about 2.4 million meters, or 2.4 million steps during a season, assuming it's off by a factor of 4, which I think is pretty accurate. Now, that said, this doesn't matter as much as long as both materials are tested using the same conditions on the Instron, which I plan to do regardless. So, I've currently tested this part of the basketball shoe, causing it to fail in the exact spot that most shoes fail at. Now, with those tests, I've generated graphs that look very similar to this using the mode that I used for this part of the shoe was a maximum of 3 millimeter extension, a minimum of -2 millimeters at a rate of 7.5 millimeters per second. This generated a graph here with the maximum force around 300 newtons, causing this graph here. Now, one flaw of this one flaw of these tests that were done is that I used shoes that had already gone through a season of basketball. So where I'm going with the rest of the project is to use a new pair of shoes, causing them to fail after a certain amount of testing on the Instron, then testing with obviously new material here, the micro-lattice structure. The aim of the experiment, my hypothesis is that the micro-lattice structure will fail will not fail as quickly. Therefore, it will make sense to try to weave this material into the shoe, causing it not to fail as quickly, hopefully allowing people to use one pair of basketball shoes for a season instead of 2 or more.